Welcome to the Greship Corrosion channel. My name is احتشام زاده. I'm a researcher in the field of corrosion and protection of materials. Please watch video number E28 for more information about this channel. Chapter 9, Section 7, Risk-Based Inspection. In this video, RBI and Collecting Data, Accuracy versus Precision using dartboards. Examples of RBI inputs. The reference elements of a risk-based inspection program, API Recommended Practice 580. RBI and Collecting Data. An RBI assessment involves collecting data that is used to monitor changes in a company's processes, so it is essential that the systems used for collecting and reporting measurements are valid and reliable. If the measurement system cannot be trusted, then the data that it produces cannot be trusted. RBI relies on data that can be trusted. To that end, the user needs to understand the difference between precision and accuracy when it comes to risk analysis. What is accuracy? Accuracy means how close data measurements are to the true value, the state of being correct, a description of systematic errors, a measure of statistical bias. In RBI, accuracy is a function of the analysis methodology, the quality of the data, and consistency of application. What is precision? Precision means how close measurements are to each other, the state of being exact, a description of random errors, a measure of statistical variability. In RBI, precision is a function of the selected metrics and computational methods. Accuracy versus precision. In other words, accuracy describes the difference between the measurements and the actual value, while precision describes the variation between repeated measurements using the same method or technique. The accuracy of any type of RBI analysis depends on using a sound methodology, quality data, and qualified personnel. Precision can be broken down further into two components. 1. Repeatability. The variation observed when the same operator measures the same part repeatedly with the same device. 2. Reproducibility. The variation observed when different operators measure the same part using the same device. Concerning precision in RBI data, the basis for predicted damage and rates, the level of confidence in inspection data, the technique used to perform the inspection are all factors that should be considered. For example, API Recommended Practice 581 is an example of a semi-quantitative RBI method that is highly reproducible due to rigorous calculations. Conversely, a qualitative RBI method is less reproducible due to the subjectivity introduced by expert opinion. Note: quantitative analysis uses logic models to calculate probabilities and consequences of failure. These logic models, which are used to characterize materials damage of equipment and to determine the COF, can have significant variability and therefore can introduce error and inaccuracy that impacts the quality of the risk assessment. The dartboard to visualize the difference between the two concepts. This is accurate and precise. This is not accurate but precise. This is relatively accurate but not precise. This is neither accurate nor precise. Accuracy versus precision using dartboards. A. Accurate and precise. High quality data, detailed procedures, rigorous, reproducible, and repeatable calculations. B. Precise but not accurate. detailed procedures, repeatable calculations, good calibration, but to wrong value. C. Accurate but not precise. Quality data, reproducible calculations, calibration required. D. Neither accurate nor precise. Subjective opinions, vague procedures, little or no calculations. Another example of data program control. The mean of the data sample is about the true value and there is low standard deviation in the sample. The mean of the sample is not close to the true value, but the standard deviation for the sample is low. The mean of the sample is close to the true value, but there is a high standard deviation. The mean of the sample is not close to the true value, and there is a high standard deviation. The result would be free from errors. The result is in disagreement with the expected one. There are meaningful variations in the measurements. The results will lack correctness and exactness at the same time. The effect of RBI procedure on both accuracy and precision. The procedure used to execute the RBI methodology can have significant impact on both accuracy and precision. If no procedure exists, the likely output for both semi-quantitative and qualitative RBI processes would be neither accurate nor precise. A detailed and complete procedure for a qualitative program will likely give an output that is accurate but not precise. This is due to the amount of subject matter expert input into the program that could cause variance based upon the individual's experience. A detailed and complete semi-quantitative procedure, for example, API Recommended Practice 581 methodology, that does not check the data inputs into the program would give consistent results that are precise but may not be accurate. RBI inputs. Examples of RBI inputs that can affect accuracy and precision are shown in the next slides according to API RP 580. The first column is the example, the second column is impact on accuracy, and the third column is impact on precision. NDE use of radiography versus straight beam ultrasonics. Straight beam ultrasonics from a qualified technician provides more accurate thickness results than radiography. The precision of radiography largely depends on the procedure being used and the reproducibility of the inspection results executed by the same NDE technician. NDE, non-destructive examination. UT, ultrasonic testing. NDE, use of radiography versus angle beam ultrasonics. Depending on the type of flaw being detected, the accuracy between these two NDE techniques will differ. For example, radiography is better at detecting porosity, versus UT angle beam is better at detecting a lack of sidewall fusion. Individual technician variance in executing and interpreting the NDE results. Use of NDE screening techniques. Screening techniques for wall thickness that detect volumetric corrosion wall losses infer a wall loss based upon estimated defect dimensions, for example, guided wave or PEC. Thus, screening techniques are not as accurate as direct measurement techniques. PEC stands for pulsed eddy current. Usage of GUL at interval inspection versus GUL fixed mounted sensor will impact the precision of NDE results. 5% versus 1%, making the fixed mounted sensor more precise. GUL technology offers pipeline inspection solutions using techniques like guided wave ultrasonic testing. It enables rapid assessment of pipe conditions with minimal insulation removal. The technology helps in quickly locating, cracking, and other potential issues within pipelines and piping systems. GUL also provides long-range screening systems and scanning capabilities for more detailed inspections, enhancing productivity and performance. NDE technician-to-technician differences and qualification tests. Qualification test will determine how accurate a technician is at detecting flaws and anomalies. As the tests have sizing limits, a technician needs to remain within to obtain credit for finding the flaw. Impact on precision. From a qualification test, it can be determined if the technician consistently over or undersizing flaws. This data could be offset by a constant to make the measurements more accurate. Another example, pressure and temperature sensors gauges. Having redundant sensors providing two readings for pressure and temperature, calibration and maintenance of sensors maintains sensor gauge accuracy. A pressure or temperature sensor sending real-time data provides more accurate real-time data for analysis than operator rounds taking readings from gauges. Pressure and temperature sensors can drift over time, providing either consistently higher or lower readings, thus being highly precise but not accurate. Another example, process composition, for example, weight more persons. Accuracy largely will depend upon the type of device being used to measure process containments, for example, Dräger tubes versus gas chromatograph for measuring H2S. Calibration of measurement devices also impacts accuracy. Impact on precision. Type of device being used to measure process containments can have variation when measuring the same sample. For example, Dräger tubes versus gas chromatograph for measuring H2S. Examples of variables impacting accuracy of RBI assessments are as following. 1. Competency of personnel supplying and validating the inputs, causing poor data that will likely lead to inaccurate RBI results. 2. Process excursions potentially missing credible damage mechanisms as part of the RBI assessment. 3. Equipment information. A. Materials of construction. Improper identification of materials of construction, either through improper management of documents or documentation of repairs, can impact the selection of credible damage mechanisms. B. Correct damage mechanism assignment. Poor process or competency of individuals executing damage mechanism assessment can impact the identification of credible damage mechanisms and thus impact the accuracy of the overall RBI process. Flawed logic. Where accuracy and/or precision problems are encountered with RBI data, focus on improving the measurement system before relying on the data and moving forward with the RBI assessment. The accuracy and precision of data are increasingly critical to ensure repeatable and reproducible results of the selected RBI methodology. Further, within RBI, the implied linkage of precision and accuracy may not exist because of the element of uncertainty that is inherent with probabilities and consequences. In practice, there are often many extraneous factors that will affect the estimate of deterioration or POF as well as the magnitude of a failure, COF, that cannot be fully considered with a fixed model. Therefore, it may be beneficial to use quantitative and qualitative methods in a complementary fashion to produce the most effective and efficient risk assessment, as well as one that maximizes accuracy and precision of both data and results. Challenge number 45. Thank you for your time and attention. If you like to challenge yourself, please answer these questions in the comments below. 1. Compare accuracy and precision using a dartboard. 2. Measurement systems can suffer from both accuracy and precision problems. Are screening techniques that detect volumetric corrosion wall losses as accurate as direct measurement techniques?